Like many of you, I'm a big fan of fighter aircraft, especially the World War II variety, as I think they represented the pinnacle of propeller-driven fighter aircraft. And today, I've got this beauty. This is the Hangar 9 F6F Hellcat, arguably probably one of the most important aircraft of the Pacific Theater in World War II. They come out with this really nice 15cc sized ARF, and this is really a beauty, 64-inch, all wood construction. I really look forward to putting it together. So without any further delay, let's take her apart and see what she looks like. Out of the box, there are several big bits and a couple of baggies of little bits. The first thing I noticed was there was some noticeable wrinkling on the covering. This is not that unusual for film-covered models, and I was easily able to rectify the issue by going over all the parts with a heat gun. As you can see, a few seconds with the gun shrinks the covering up quite nicely. For sheeted surfaces, press down on the hot film using a sock or other soft material. The fiberglass cowl is well made with a durable weave. The glossy gel coat is very nice, with details such as panel lines and simulated vents. The wing looks to be a D-tube construction with open structures in the middle. Aileron servo pull strings are pre-installed for convenience. The all-wood fuselage is well built and sturdy, and has the tail wheel mount installed at the factory. Firewall has some scale exhaust exit depressions, and I also noted the epoxy fuel proofing pre-applied to the motor mount area. Two small nylon screws hold the large top hatch on. Which opens up a fairly large and cavernous fuselage interior with plywood servo mounts. The hatch itself is all balsa with a painted cockpit area and instrument panel decal. A bag of goodies includes a 15-ounce fuel tank, gear cover and wheels, and of course, a pilot figure. Manual is clear and well organized with black and white photos for every step. Even shows a proper way to balance the model. Starting with the ailerons. Mask off the horn slot. Roughen the fiberglass horn. Then epoxy in place. When cured, insert back into the wing and glue the hinges with thin CA. Remove the servo plate and open up the screw holes with a small drill. The servos I'll be using are the Spektrum A6390 standard size aircraft servos. At 66 inches of torque, they will have more than enough power. With rubber grommets and metal eyelets installed, mount the servos into the bracket plate with screws. Excess arms on the servo horn are cut off before test fitting in place. Now I should note that the servo cases make great parts containers. Use the strings to pull the servo leads through the wing. I needed to drill out the control horns just a bit larger for the control link clevis. Once the servo is in place, the pre-assembled control rod is mounted and adjusted to length. Works like a charm. The Hellcat requires 95-degree rotating retracts. These e-flite units are all metal and look to be very durable. Actuation is simple and reliable. The pre-painted wheel wells are best trimmed with curved scissors. Carefully trim off the excess pieces, then sand the lip in preparation for gluing. Now locate the wheel well opening under the covering and open up using a sharp-bladed hobby knife. Carefully sand around the edges and glue in the inserts with epoxy. Use tape to hold in place while everything dries. Got gear? Well, if you do, now's the time to mount those babies into the wing. I needed to make a small hook to pull the servo wires out, but the machine screws went in with no issues. Add on the wheel shaft, and lower the gear before mounting the wheels into place. The tires are solid foam, but not overly hard. Use a pair of wheel collars as spacers and keepers. Also make sure there is a bit of toe-in for stability. Assemble the gear covers per the manual. And test fit with the gear retracted in order to mark the alignment. Scuff up the gear wires to prep for gluing. I will be using micro balloons, which thickens up the epoxy a bit. Add a small amount to the epoxy mix. Then spread onto the strut mounts. When the epoxy is partially dry, retract the gear and adjust for fine alignment. Tamiya Royal Blue acrylic model paint can be used to touch up the exposed white plastic. At this point, the wings are finished and can be mounted to the fuselage. Nylon thumb screws hold the wing on. We move on to the tail, and after removing the control surface, test fit the stab to the tail and check that it is level. Yep, looks good to me. Glue that puppy on with your favorite epoxy. I like 30-minute. Be sure to clean up your mess before checking that the tail is on straight. A couple of large clamps are then used to hold it in place tightly for a good bond. While that dries, disassemble the elevator and glue in the metal joiner. Like the ailerons, the elevator hinges are glued using thin CA. Mounting the vertical fin is déjà vu. Don't forget to check alignment. The tail servos went in without any issues. Long rods are slid through the guide tubes in the fuselage and connected just like the ailerons were. Silicone tubing prevents any accidental disconnections. Moving on to the steerable tail wheel, which is basically set up like a typical nose wheel mechanism, except it's in the tail. The opening is covered with painted foreign plastic trimmed to size. Instead of glue, I used double-sided tape to hold it in place. Mounting the motor box is made easy using the supplied template. Use the template markings to drill the pilot holes. Insert the blind nuts, then screw in the electric motor box. Be sure to use thread lock on the screws. Motor mount screw holes are already marked on the box for your convenience. And yes, more blind nuts. The recommended motor is the e-flite Power 60. It's a nice hefty motor rated at about 1800 watts, more than enough to pull the Hellcat through the air with ease. A powerful motor needs a powerful speed controller. In this case, it's the Spektrum AVN Smart ESC. This cooling fan-equipped controller can send telemetry data to compatible receivers. To prepare the wood for mounting the ESC, a thin layer of epoxy is spread on the side of the box. And while I was at it, I spread some epoxy on a battery tray. This is done to make a smooth surface for the Velcro to stick to. I also drilled some holes for zip ties, which I'll use to add extra security. Then I screwed in the battery tray. So the pilot figure is pretty nicely detailed and pre-painted with... Hey, wait a minute. That's a German Knight's Cross medal. Oh well, it'll be our little secret. So glue her Oberlieutenant John Smith into the cockpit with craft glue. The canopy itself is nicely masked and painted and needs no trimming. Glue on the canopy with, no surprise, canopy glue. Back on the nose, where we trim down the dummy engine cylinders. And open up the center for the motor. I started with drills of increasing size, but I quickly found the plastic too brittle for that technique. Instead, I carefully opened up the hole a bit with a hobby knife. Then use a rotary tool with a sanding drum to enlarge the hole. To make an extra cooling hole, I first scored the outline with a hobby knife. Then I drilled some small holes in the corners. Finally, cutting out the remaining with a knife. For extra detail, you can use the included simulated push rods, which must be glued into place. Now glue the cylinder assembly into the cowl. Next, mark the cowl mounting tab location using scrap paper and tape. Test fit the prop and check for alignment of the front. When everything looks good, then drill the pilot holes before inserting the cowl screws. 2 large decal sheets are included in the kit. Simply peel and stick. For large decals, I use painter's tape to mark the location and alignment before sticking them on. I use my usual technique of using window cleaner so as to allow fine positioning of the decal, which didn't go quite as planned. Okay, so I'm on the home stretch. I'm really just putting the final touches onto the Hellcat. And I've run into a couple of little, I don't know what you call them, say, nitpicks, oopsies. So the first one is the decals. Now, my normal technique of using window cleaner to put on a decal seems to not have worked that well this time. I don't know why, but as you can see, I've got a bit of frosting going on with some of the clear parts. Now, I've seen this before, and it always clears up after a little while of drying, but after letting it dry overnight, it didn't clear up, and I don't know why, so that's very unusual. So it can be fixed, but what I have to do is, I think, is just basically pull the decals off and retrim them close to the edges and put them back on again. I can either do that for the 35 here, but fortunately the kit also comes with the number 9 decals for an alternate paint scheme, so I might just be lazy and put the 9s on instead of the 32s. So that's a little weird, but that's okay. I can certainly get over that. Just want to let you know that if you have this kit, don't use water or a window cleaner. Just put them on dry and just be real careful with it. So the second thing is I was playing around with the telemetry, and I'll get to that later on in this video. The telemetry from the speed controller was showing me that it was putting out 7 volts from the BEC, and I said, is that right? So I actually checked it manually with a voltmeter, and indeed it was right. It was putting out 7.5 volts. And it was that surprising because normally speed controllers default to about 5-6 volts. Fortunately, I didn't have much plugged in. I did have a couple servos plugged in, but they seem to be working fine. But I double checked, and the retracts are only rated for up to 6 volts. So it's a good thing I didn't plug the retracts in, because I was in danger of blowing those up. So fortunately, what I'm going to do is try to reprogram the speed controller. It has a programmable BEC, so I'm going to kick the voltage down a bit so I won't be in danger of harming the retracts. A couple little nit things. Good thing I caught them early, and I think I will go and fix those problems right now. So to fix my botched decals, I've carefully peeled off the offending livery. Then, on a non-stick surface, I trimmed off the clear parts. Since the stars and bars are now in 3 pieces, a straight edge to the rescue. Bye-bye 32, I hardly knew ye. I dare say that looks even better than before. Time to reprogram the speed controller. Plug in the battery after setting the transmitter to full throttle. Then reference the manual for the correct tone sequences. Quickly move the throttle down when the magic tones are heard. Scroll to the telemetry screen, and, oh yeah, 6 volts of electromotive force. A sanity check with the voltmeter shows the telemetry is right on the mark. Now I can plug everything up with a warm feeling in my soul. Elevator throws were a bit excessive at first, so I dialed down the travel endpoints a bit. Much better. The ailerons needed differential throws, meaning more up than down. To do that, you have to offset the servo horn while in the neutral position. Having more up than down helps prevent tip stalling at low speeds. Without nose weight, the model wouldn't balance. 8 ounces of fishing weight seemed to do the trick. Drill out the center and into the motor box. Then screw in place with nylon locking nuts. It's like they wanted me to mount it there. And with that, we are ready for flight. Okay, so one last thing. I recently picked up this DX8 G2 transmitter, and one of the neat things about it is the built-in telemetry. So what I have for this kit is I have the smart speed controller and the 6610 telemetry receiver. So I'm a newbie with the telemetry for the Spektrum series, so this has been really interesting. So I thought I would set up some of the telemetry with the Hellcat, and let's take a look at what I did. Look, Ma. No more bind plugs. Binding is now a simple push-up button operation with the 6610 telemetry receiver. Setting up the telemetry is super simple. After binding, select Telemetry from the main menu, and then select Auto Config. This will cause the transmitter to automatically populate the telemetry displays. You can then go in and manually adjust the alarm values like I'm doing here with the battery low voltage settings. Using the telemetry is great for checking performance numbers. I see them right on the edge of max current with the 16.8 prop. The low voltage warning works as well.
21.8 volts, 43 amps, 81 Fahrenheit.
She also notes when you unplug the battery.
ESC, no data.
Oh, I'm sorry, honey. One last nitpick was that the canopy hatch screws were hard to screw in until I opened up the holes a bit, as they were misaligned slightly. There we go, much better. Okay, no more excuses. Oh, wait, I got an excuse. Okay, no more excuses. She's ready to go. I can't think of anything else to do. Everything's set up correctly. Telemetry's working. We're just waiting for the next opportunity to take her out. I'm gonna fly her like I stole her. Well, no, I didn't really steal her. I'm not gonna fly that way, but I really anticipate looking forward to getting her up in the air and see how she handles. It's really a fine looking model. It went together really well. A few nitpicks here and there, but it's really minor stuff that almost any kit has. But other than that, she's a fine looking lassie, and we will see you on part 2 when I take her out to the field and give her a try.
ESC, no data.